Welcome to Brain Vision.
We begin this question by calculating the acceleration of the boat. So before at t equals 0, its velocity was 15 degrees north of the east. So let us decompose this velocity in its x and y components. And I'm choosing x and y components as follows. This will be my y direction and this will be my x direction. Therefore, the x component of the velocity at t equals 0 is equals to 2 times the cosine of 15 degrees, because the east direction coincides with the x direction. And the y component will be equals to 2 times the sine of 15 degrees. Now, at t equals 30, we have the following. The x component of the velocity is equals to 4 times the cosine of 35 degrees. The y component is equals to 4 times the sine of 35 degrees. Then, we can now calculate the acceleration during these 30 seconds. We have the following. The x acceleration is equals to the variation in the x component of the velocity divided by the time interval. So we have 4 times the cosine of 35 degrees minus 2 times the cosine of 15 degrees divided by 30 seconds. And this is approximately 0.045 meters per second squared. Now, for the y component, we have the following. The variation in the y component of the velocity divided by the time interval. And this is equals to 4 times the sine of 35 degrees minus 2 times the sine of 15 degrees divided by 30 seconds, which is approximately 0.059 meters per second squared. Now let me organize the board. Okay, now we calculate the net force in each direction, x and y. And it goes as follows. So on the x direction, the net force is equals to the following. It's equals to the wind force on the x direction, which we don't know yet, plus 31 times the cosine of 15 degrees, which is the x component of this force, minus 23 times the cosine of 15 degrees, which is the x component of this force. It's negative because it's pointing to the left. This gives us a x component of the net force as Fwx plus 7.727. For the y direction, we have the following. The net force on the y direction is equals to the wind force on the y direction plus 31 times the sine of 15 degrees minus 23 times the sine of 15 degrees. And this gives us a net force on the y direction of Fwy plus 2.071. Now, let me organize the board again. Fine. Now that we know both the net forces and the acceleration in each direction, we can use Newton's second law to calculate what are the components of the wind force. It goes as follows. For the x component, we have that the net force on the x direction is equals to the mass of the boat times the acceleration in the x direction. So, Fwx plus 7.727 is equals to 325 kilograms times 0.045. So the x component of the wind force is equals to 325 times 0.045 minus 7.727, and this is approximately 6.9 newtons. Now, repeating the idea for the y component, we get the net force on the y direction is equal to the mass times the acceleration in the y direction. So Fwy plus 2.071 is equals to 325 times 0.059. Then Fwy is equals to 325 times 0.059 minus 2.071, which is approximately 17.1 newtons. Now, let me organize the board again. Now that we know both components of the wind force, we can combine them to calculate the magnitude of the wind force. Using the Pythagorean theorem, we get a wind force that is equals to the square root of Fwx squared plus Fwy squared. Then Fw is equals to the square root of 6.9 squared plus 17.1 squared, which is approximately 18.4 newtons. So this is the magnitude of the wind force. Now, let us calculate its direction. So the tangent of the angle that the wind force makes with the x-axis is equals to the y component of the wind force divided by the x component of the wind force, which is equals to 17.1 divided by 6.9, and this is approximately 2.5. Then the angle that the wind force makes with the x-axis is equals to the inverse tangent of 2.5, and this gives us an angle of approximately 68 degrees. So the wind force can be drawn as follows. Here is the east direction, and then we have a wind force of 18.4 newtons, 0.68 degrees north of the east. So 18.4 newtons force pointing 68 degrees north of the east.